Next, we are going to discuss what the subnet mask does. Now, just like your home address has two portions. You have your street address and then your house number. So let's go with 21 Jump Street. The street address is Jump Street and the house number is 21. Just like that, your IP address has two portions. It has a network portion, which corresponds to the street address, and then it has a host portion, which corresponds to the house address. What the subnet mask does, it separates the street portion of the address from the house portion of the address. So a subnet mask separates the network address from the host address. I have drawn out in binary 4 octets for the IP and 4 octets for the subnet mask. And the IP we are going to be converting to binary is 200, 10, 10, 10, and the subnet mask being the Class C subnet mask. Since 200 falls in the Class C range, it is a number between 192 and 223. So the subnet mask has to be 255, 255, 255, and then 0. If the octets are not clearly visible on camera, I have drawn out a bigger octet on top here. Each one of these fields between the dots looks like this, with the numbers going from 1, then double 2, 4, 8, 16, 32, 64, and 128. So let's convert the IP into binary. 200. How do I get 200? 128 plus 64 is 192, plus 8 plus 2 is 200. Plus 8 is 200, sorry. 192 plus 8 is 200. Then the second octet is 10, which is simply 8 and 2. So 8 plus 2 is 10. The third octet is also 10, which is 8 plus 2. And the fourth octet, I'm going to be off camera here for a second. I didn't have enough space to draw this out larger than that. 8 and 2, and the rest are zeros. Now let's look at the subnet mask. The first octet is 255. How do I get 255? Once again, all the bits are turned on. So 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 gives you 255. The second octet is also 255. So is the third octet. And the fourth octet is 0, which means all zeros. This is how subnet mask works. For any bit in the IP address, so bit value 128 we're looking at. So for any bit in the IP address, if the corresponding bit in the subnet mask is on, then that bit in the IP address belongs to the network portion of the address, or the street portion of your address. So 128 belongs to the network portion because the corresponding bit in the subnet mask is on. How about this 32-bit? The bit in the IP address is off, but that doesn't matter. If the corresponding bit in the subnet mask is turned on, then this bit belongs to the network. So it does not matter whether the bit in the IP address is on with the value 1 or off with the value 0. As long as the corresponding bit in the subnet mask is on, that bit belongs to the network. So this first whole octet has on bits in the subnet mask. The corresponding bits for the IP in the subnet mask are all on. This first octet, the whole thing belongs to the network. So does the second octet, because the corresponding bit for the IP, the corresponding bits in the subnet mask for this IP address, the corresponding bits are on. So the second octet also belongs to the network, and so does the third octet. The fourth octet, for the bits in the IP, the corresponding bits in the subnet mask are all off. So that portion of the IP address belongs to the host portion. So if you see, the first, second, and third octet have the bits in the subnet mask as on. So the first, second, and third octet belong to the network up until this point. The last octet all belongs to the host address, or 4 host addresses. So if at this point I were to ask you, give me just the street name, give me just the network address, you would say, or I would expect you to say, I'm going to erase this top, the network address is 200.10.10. In the computer world, we can't just leave a field empty. So we simply put a 0 here. So the street number for this IP address, just the street number or the network address, is 200.10.10.0. And again, this is /24 or 255.255.255.0. 8 bits plus 8 bits plus 8 bits is 24 bits, hence /24. Now, the first valid address on this street, or the first house on this street, is simply 200.10.10.1. If I were to ask you how many total houses can you have on this street, or in other words, what is the last address on this street? Well, as you have seen, if an octet is full, so you take any octet and turn all the bits on, that's the maximum number you can derive from it, which is 255. So the last address on this street is going to be 200.10.10.255. 200.10.10.255. Making sure these dots are visible for you guys. So the rule in all networks being is that you cannot use the first address and the last address in any network for your PC. You cannot assign a PC or any machine the first address and the last address in a network. Why? Well, because the first address, the .0 address, is the network address itself. So if you asked for my home address and I told you I live on Jump Street, would you be able to get to my house? No, you would just be able to get to my street. So assigning this address to a machine is not allowed because it is just the street address or the network address. The last address in any network is the broadcast. Any message sent to this address will be received by all houses on that street, or any message sent to the .255 address will be received by all hosts in this network. My valid range of addresses, and I'm going to erase this 10 here, we don't really need it anymore. The valid range of addresses that are assignable to PCs is .1 through .254. This is your valid range. The valid range of addresses can also be achieved using a formula. You could use the formula 2 to the power n minus 2, where n equals number of host bits. How many host bits do I have in this network 200.10.10.0? Well, since the mask is 255, 255, 255, 0, the first octet belongs to the network. The second octet belongs to the network. The third octet belongs to the network. The fourth octet, the last octet, belongs to hosts. How many bits are in this last octet? 8. So 2 to the power n minus 2, where n is the number of host bits, you could say 2 to the power 8 minus 2, which is 256 minus 2, which is 254, which gives you the same number we got here. The valid range is .1 through .254. So 254 total valid addresses. Let's look at another example. What if we have a Class B address? So 150 is a number between 128 and 191, which makes it a Class B address. So let's say we have 150.100.10.10. And the mask is 255.255 If I were to ask you what the street name is, or just the network address, because this is an IP address, this is a host address. So if I were to ask you just for the network address, I would expect you to answer 150.100.0.0/16. Why 150.100.0.0? Because the first octet belongs to the network and the second octet belongs to the network. The third and fourth octet belong to host addresses. So we just set them to 0 for the street name or the network name. Why the /16 here? Because 8 bits turned on in the subnet mask here, plus 8 bits turned on in the subnet mask in the second octet. So 8 plus 8 is 16. If I were to ask you for the first valid address here, you would say 150.100.0.1. Why 0.1? Well, the octet to the rightmost octet has to be full before you add 1 to the octet to the left of it. So this would go 0.1, 0.2, 0.3, 0.4, all the way through 0.255. Then you would have 1.0, 1.1, 1.2, 1.3, all the way through 1.255. Then you would have 2.0, 2.1, and so on and so forth. Well, I'll just erase this. The last possible address would be 150.100.255.255. Both the octets are full. Of course, this last address would be your broadcast address. Again, any data sent to this address will be received by all hosts on the network. So, my first valid address was 150.101.0.1. My last valid address would be 150.100.255.254. This would be 0.1 through 255.254 would be my valid range. If I were to use that 2 to the power n minus 2 formula, and the minus 2 because you can't use the first and the last address. The last address being the broadcast address, and the first address being the network or the street address itself. If I were to come up with how many total addresses are between 0.1 and 255.254, I could use the formula 2 to the power n minus 2. The minus 2 because we take away the first and the last address. So in this case, the value of n. Well, how many host bits do we have? The first octet belongs to the network because all the bits underneath in the subnet mask are turned on. The second octet belongs again to the network because all the bits in the subnet mask are turned on. The third and fourth octet belong to host addresses. So this is 8 bits plus 8 bits, 16 bits. 2 to the power 16 minus 2. So 2 to the power 16 is, I believe, 65,536 minus 2, which is 65,534. Now let's do a Class A example. I'm going to pick a Class A IP 10, 10, 10, 10. Keep it simple. The mask for Class A, since the first octet, the value is between 1 and 126. My subnet mask is 255.0.0.0. So if I were to ask you just for the street name, just for the network address, you should say it is 10.0.0.0/8. Why /8? Because only 8 bits total are turned on in the subnet mask, meaning the first octet, the whole first octet. Now, the first valid address in this case would be 10.0.0.1. Then it would go to 10.0.0.2, .3, .4, all the way to 10.0.0.255. Then it would go 10.0.2.0, 2.1, 2.255, 3. And so on and so forth. When this number gets to 255, then you will add 1 over here. The last possible address for a class A would be, or for this IP class A, would be 10.255.255.255, which of course is your broadcast. The first address, of course, is your network address. This first address and this last address are unusable. The first address being the street address or the network address itself, and the last address being the broadcast. Again, any message sent to this address will be received by all hosts or all devices on the network. The last valid address would be 10.255.255.254. So this 10.0.0.1 through 10.255.255.254 would be my valid range. These are assignable addresses that I can provide to machines, to computers, to PCs, to printers. Now, if you were to ask me what is the total range of addresses between .1 and .254, let's see if I remember. So this would be, again, 2 to the power n minus 2. Minus 2, once again, we take away the first and the last address, hence we say minus 2. So this is going to be 2 to the power. The first octet belongs to the network, so that's gone. The second, third, and fourth octet belongs to host addresses. So this is 2 to the power 24 minus 2, and I believe 2 to the power 24 is 16777,216 minus 2, which yields 16777,214 addresses. And that concludes the class-full IP addressing portion of this class. Next up, we're going to get into classless IP addressing.